your hand, and we will be able to assist you. Okay, so introduction to transmission media. This is the very first chapter in version 2.5. So let's go through it. So establishment of an enterprise network requires a fundamental understanding of general networking concepts. These concepts include of what defines a network, as well as the general standards of technology and physical components that are used to establish enterprise networks. An understanding of the underlying network communication and the impact that such behavior has on the network is also paramount to ensuring performance effective implementation. By the end of this chapter, you should be able to. Lynn, you can assist us. Lynn, are you there?
Yes, I can hear you back.
Okay, go ahead.
My laptop is a bit slow.
Okay.
My screen is still at forward.
Oh,
So I can't read the rest of it. It's a bit slow. My network is having issues.
oh, sorry. I think that's my on my end. Nime move na haijasonga. What about the rest? When I move, do you see? Nikiwa nimenini hivyo inasonga?
When it's okay.
Oh, kwa hivyo inasonga? Yes. Na sawa, haina shida. Ni sawa Lynn. Someone else can read for us? Yes, Gibran?
I think I can come in so that we save time.
Yes.
So the objectives, upon completion of this section, you will be able to, 1, explain what constitutes a network.
Yes.
2, identify the basic components of a network. And 3, describe the primary mechanisms for communication over a network.
Exactly. Okay. So a network can be understood as having at least 2 end stations. 2 end stations and a medium over which they can communicate. 2 end station and a medium over which they can communicate. Now, generally, we have 2 types of media. So we can either have a physical medium, and we can also have, I think, what we call a wireless medium, physical and wireless. Now, generally, when you talk of physical medium, we are either using electrical signals, or we are using light signals. On the other hand, when it comes to wireless medium, we are using radio waves. So don't forget that. Now, after having the 2 end stations and a medium over which they can communicate, the other thing we must have is the end station must have the ability to transmit. Most of the time, the device that is transmitting, we call it the TX. And the other device must have the ability to receive. And most of the time, we call this device that is receiving the RX. So transmission and reception. Very important. Okay. Now, generally, this is what we call, when we interconnect 2 end stations that have that are on the same level. The same level in terms of, what can I say? They're on the same level in terms of especially the layer. You remember the layered architecture. So we have the access layer, so they have the same abilities. Let me put it that way. So anytime we are interconnecting, for example, a phone and another phone via Bluetooth, we call that kind of network a point-to-point network, a point-to-point network. Now, generally, when we are talking about the enterprise network, we will commonly be referring to it as the Ethernet network, the Ethernet network. The reason as to why is because we have a physical medium. We have a physical medium, as you're going to see, that is called the Ethernet. And it's the one that is commonly used within the enterprise network. And therefore, generally, a computer network is commonly interchangeably referred to as an Ethernet network. An Ethernet network. So it's important that you understand that. So now, let's look at some of the physical medium that we have. So one of them is this guy here. This guy is called the coaxial cable. The coaxial cable uses electrical signals to transmit data from the sender to the receiver. And there are a few things that you must be aware of when it comes to this medium. One of them is the Okay, sorry, ni kama internet yangu ilinitupa nje. Nilikuwa nimefika wapi? Hello guys.
On coaxial cable.
Okay, on coaxial cable. Let me just go back there so that we proceed. Okay. So the coaxial cable. The coaxial cable. Now, there are a few things that you must know about each of the transmission medium that you're going to learn here today. One of them is you must be aware of the standards that are available. The other thing you must be aware of is their names. The other thing is their transmission speed, and lastly, the transmission distance, maximum transmission distance. So you must understand these things about each cable. Good thing is that most of the time, the standard will give you the transmission speed. So for example, with coaxial cable, we have two standards, the 10^2 and the 10^5. Now, on the standard name, most of the time, this value on the left will give you the maximum transmission speed. So for example, the maximum transmission speed for a coaxial cable, in both standards is actually 10 Mbps. So 10 Mbps is 10 megabits per second. 10 megabits per second, as you can see. Then this other value here should now be able to differentiate the two particular standards. So we have 10^2 and 10^5. Now by name, this first one, 10^2, is called a thin coaxial. The reason as to why it's called a thin coaxial is because at the very center of the coaxial cable, we have a copper wire. And this copper wire, as you can see, they differ in terms of circumference. So the one with a thinner wire in the middle is called a thin coaxial cable. Then the one with a thicker one is called a thick coaxial cable, or thinnet and thicknet. Now the other important information that you should know is the maximum transmission distance. So with 10^2, it can do a maximum of 185 meters. Now generally, the reason as to why we have a recommended maximum transmission distance is because of an electromagnetic concept we call attenuation. So attenuation generally is loss of loss of power,
Signal.
loss of signal strength, exactly, strength over distance as it travels over the particular medium, loss of signal strength. So that is what we call attenuation. So that's why we have a recommended maximum transmission distance. So if you're using a 10^2, you cannot interconnect devices that are further beyond this recommended distance. If you do that, then you're going to have data loss. Attenuation will cause data loss. It's not going to be possible to reconstruct that particular signal at the receiving end. So I hope that is clear. Now, the other thing that I almost forgot that is very important about each of these particular medium is what we call the connector. The connector. So, for example, for 10^2, we have what we call the BNC connector. It's normally called the bayonet nail concealment connector. So this guy here is what we call the bayonet nail concealment connector. Maybe just to ask one of you, I'm sure you've seen this. Where have you seen this kind of connector and also this kind of cable? Anyone? Yes, Bethel? Yes?
I have seen it for the one used for TV signal connection.
Exactly. So actually, this is what we've been using for all the years in connecting the aerial to the TV. Unfortunately, in our enterprise networks, we no longer use either of these cables. Reason being, these speeds cannot support the requirement of today's network. So we no longer use this. We no longer use them, but it's important that you understand its composition. So at the very middle, we have a copper wire. Then we have a white insulation. So an insulation is just something made of plastic, an insulator. Then after that insulation, we have another copper wire. And at the top, it is also protected with another insulation called a sheath. So we have an inner sheath and an outer sheath. So those are like the four parts. Most of the time, just above this inner sheath, we can have an aluminum foil. That aluminum foil is used to prevent what we call EMC or electromagnetic interference. Electromagnetic interference between the two cables. So I think that is about it. That is all you need to know about the coaxial cable. Yes, Nick, you have a question, Kilonzo? Have you put up your hand? Okay, so let's look at the Ethernet cable. As I said, the enterprise network is commonly referred to as the Ethernet network. Reason being, this cable is widely used within the enterprise network. This particular cable uses a connector called the RJ45 cable. RJ45 cable, and the cable itself is made up of four pairs of intertwined copper cables. So these are four pairs of intertwined copper cables, and most of the time it has this cable here, which is actually something like a fiber that is used to ensure that you cannot be able to stretch. You cannot be able to stretch and cut these copper wires. So this thing you're seeing here is simply a strong kind of material that is used to protect you from being able to stretch and cut these four paired cables. Now we have these three standards and we have many other that have come up so far. 10 base T can transmit to us maximum speed of 10 megabits per second, TX 100 megabits per second, then 1000 megabits per second, or 1 gig for 1000 base T. Now with 10 base T, it uses two pairs of twisted cables. Those twisted cables can be referred to as either Cat3, Cat4, or Cat5. With 10 base TX, it uses two pairs of Cat5. Then now we have 1000 base T that uses 4 pairs. That is what you're seeing here. 4 pairs of Cat5e. Twisted pair cables. So twisted pair, this one, they have been intertwined together, they have been twisted together in order again to reduce electromagnetic interference. One thing to note again is that the maximum transmission distance of all Ethernet cables is actually 100 meters. Again, because it uses electrical signals, it can also suffer from attenuation, and therefore the maximum recommended distance is 100 meters. Okay, so any question about the Ethernet cable? So I said this guy is called the RJ45, right? RJ45. So most computers are interconnected with RJ45 or end stations. Yes, Gibran?
Maybe for the sake of my colleagues,
Yes.
for the cable, the part that you say that it forms like a strength for the cable not to stretch it.
Exactly.
More to it, it normally acts as a separator for the 4 pairs of cable, for the 4 pairs.
Uh-huh.
And the separation is basically for the EMI interference. So it tends to balance the cable. So it actually helps as well to balance the cable.
Okay. So I think I'm
Because
also
of the electrical, yeah. Other than that,
kanakwanga
the reason.
kameundwa na nini? Inakuwa imeundwa na nini hiyo material? Ni fiber? Ama ni nini?
Yeah, it's actually fiber or fiber to plastic. It is in between there. Yes.
Okay, so inasaidia to prevent from stretching, and as Gibran has told us, Gibran has over 10 years experience in computer networking and is a good friend to me. So it also acts as a separator.
Yes.
Told in order to reduce electromagnetic interference. Electromagnetic interference ni simply put, sijui kama ushaitumia simu ukasikia saa zingine maneno ya watu wengine, hizo ni hizo simu za kitambo, sijui hata naweza explain aje, but ni signals zenye ziko kwa line nyingine zinaingia kwa line nyingine.
Yeah. Basically, electromagnetic interference occurs as a result of transmission, because this is electrical signals that traverse through the medium.
Yes.
So, because the 4 pairs are in use, it tends to form like a magnetic magnetic fields. So,
yes.
So to cancel that, for those of us who did physics, maybe they know what a balanced modulator is. So if they understand the modulators how are done, where you have the 4 sides and in the middle is like a balance, that a bridge that is made. So that is what normally happens. It's actually physics applied to how the cable is structured.
Kabisa. True. Yes. Okay, thank you. So the other thing as a network engineer that you must know is how to interconnect these two, the cable to the connector. So you can find a video on YouTube. These connectors cost about 10 to 15 shillings. So anywhere kwa kaunti yoyote, ukienda tu kwa duka ya computer, most likely they have this, and most likely they also have the cable. Sorry, can you still hear me?
Yes.
Okay, so when you're buying the cable again, it's always important that you check the information that is provided somewhere here on the cable, so that you can ensure that it's Cat 5e or better. As I've told you, we have Ethernet cables right now that can transmit up to 10 gig. So you transmit to 1 gig. Yes, Gibran? Gibran, you raised your hand?
Oh, sorry, I was lowering my hand.
Oh, sorry.
Sorry for that.
Hi. Okay, so good. So please check a video and learn how to do that. It's important. Just purchase it. Gibran, hii nini per meter ina cost kama how much? The Ethernet cable?
It depends.
With the
It depends with the category you're purchasing. Like, okay, right now, what is there in the market? Is category 6E.
and category 6E can do up to how many? How many gig? Is it 10 or 40?
It's still 1 gig.
Oh, 1 gig. Oh, sawa.
It's still 1 gig.
Teacher Kariuki.
Yes, sir.
Teacher Kariuki.
Yes,
How are you, sir?
Nzuri sana.
My name is Alan.
Karibu Alan, umeingia?
Niliingia.
Okay.
Okay, I wanted to just say something about the Ethernet cables.
Yes.
Hello.
Yes, go ahead.
Okay, currently at the market, we have moved from Cat 5e.
Yes.
To now we have 6, and 6 is doing good, and it's running up to 10G. It's called a 10G network. But we also have Cat 7, Cat 8.
Okay.
Cat 8. Yeah, Cat 8. No, take note of that.
Yes.
Cat 8 runs up to 30 meters.
Alan,
The others run up to 1. But cut on the yeah.
Unakatika sana. Sijui ni network yangu ama ni yako.
Nilikuwa nasema we currently on the market we are doing Cat 6A, which is doing better.
Okay.
Cat 6A, yeah, and the Cat 6A there's a good one called Simon and another one called Giganet. So Simon goes for about 22,000 for that 300 meter roll.
Okay.
There's Giganet that does up to 16,000. That 300.
Okay. Sawa, Alan. I think unapotea.
Also, sorry, also Cat 8.
Aya, sawa. I think tutaangalia zaidi kuzihusu baadaye. Asante, but
so just
what I just want to insist is that please purchase this cable. It can cost you about 150 shillings per meter. Kama ni hiyo Cat 6 na Cat 6E. And you also need what we call a crimping tool. So you can also search about that. Okay, so let's go now to fiber. This guy is the real deal right now. So when you talk of projects like FTTH, fiber to the home, using fiber, when you talk about NOFB, it is NOFB to the counties, to the sub-counties. Then now from NOFB, the telcos can tap in from NOFB and bring you internet, fiber connection up to your home. So fiber, instead of using electrical signals, fiber of course uses light signals. Uses a physics concept called, I think it is internal, what do we call it? Total internal refraction. Kwa wenye walifanya physics walisoma hii. total internal refraction. So data is converted from electrical signals to light signals. Then that light signal bounces all through from the sender to the receiver. So that is how fiber actually uses. And as you can see, one of the main advantages with using light signals is that it does not suffer from attenuation in the same way as our electrical signals counterparts. So that's why generally fiber can transmit for longer distances compared to copper. Because it does not suffer to a similar extent. It also suffers, but just a little bit. So that's one of the main advantages of fiber. So we have several standards for fiber, but generally, as you can see, 1000 base LX and 1000 base SX can both do 1 gig. Now, we have what you call a strand. A strand. So a strand is like your single piece of hair. So inside a fiber cable, it can have 2 strands. So that is what we call a 2-strand fiber. So we have two lines. You see the Cat5e Ethernet cable had 8 wires. So this one is like having 2. Yes, Lynn, you have a question? Lynn, did you raise your hand? Okay, so other than understanding what a strand is, the other thing you need to understand is whether the fiber is multimode or single mode. So with single mode fiber, you're sending 1 signal at a time. With multimode fiber, you are sharing the medium between different signals. So if that is your fiber, so that is what we call a single strand. So single mode, you're just sending one signal at a time. So it will be refracted. This is what we call total internal refraction. It will be bouncing back like that until it gets to the end. So that is single mode. On the other hand, multimode plays around with the angle of refraction, and therefore it is able to send multiple signals at the same time because it uses different angles of refraction, like that. So that is what we call multimode. One of the biggest difference between single mode and multimode is that single mode can be able to transmit data for longer distances. So when you're using a single mode fiber, you can do up to 5,000 meters. And therefore, most of the time, they're used as undersea cables, na vitu kama hiyo. But with multimode, you can only do a maximum of about 2,000 meters or lower. So you see, for example, the 1000 base SX multimode fiber can only do a maximum of 550 meters. Now, it is beyond the scope of this particular training, but these are some of the connectors that that fiber has. One of them is called the ST connector, LC, and also what we call the snap connector or SC. So if you do HCIP, this is one of the things that you're going to understand. You're going to understand each of these types of connectors. But these are just examples of fiber connectors. Okay, and then you have the serial cable. The serial cable is a legacy form of data transmission. In ICTs, when you talk of legacy, we're talking of traditional or something that has been outdated. Legacy. Why? Because of majorly the speeds. So they have very low transmission speeds. So that's why it has been outdated. They were evolved in 2 major standards, what we call the recommended standard 232 and the recommended standard 422. And those are the speeds. These ones in particular were used to connect to the printers and so on and so forth. So it's important that you understand about the serial cables. And with serial cables, they send signals one at a time, as a stream of bits, one at a time. So the opposite of serial is actually parallel. Okay, and they were also using technologies such as frame relay. Frame relay is one of the topics that was removed from here, but it is in the version 2.2 notes. So you can also learn about frame relay when you get time. Other new forms of serial cables that have come up to date is what we call the USB. The USB. And therefore, most two-way routers and switches can also be initially configured using a USB cable, also known as a universal serial bus, USB. So this is another serial cable actually that has replaced the traditional RS-32 and RS-422. Another serial cable that is common is called the firewire. You can also research more about the firewire. Okay. So let's look at what we call the signal data encoding. The signal data encoding. Just about to finish what we're supposed to do today. So we said we must have a sender and the receiver and a medium over which we want to send data. Now, signal data encoding generally are signal patterns that are used for the interpretation of communication. So these signal patterns that are used for the interpretation of communication, as you know, computers use what you call the binary language. It only understands ones and zero. So encoding is this. When we are sending a 1, we send an electrical signal. When we are sending a 0, we send an empty. We do not send any electrical signal. When we are sending a 1, we send an electrical signal. When we are not sending, when you're sending a 0, we don't send an electrical signal, like that. So as you can see here, we have a wave. We have a wave that has highs and lows. So that is what we call a signal pattern that can now be used for the interpretation of communication. And generally, this kind of encoding is used to synchronize the transmission between the sender and the receiver over the physical medium. Synchronizing is making sure that they are both communicating at a rate that they can understand. So no one is sending more than I can process at any particular time. This particular encoding mechanism is called the Manchester encoding. Manchester encoding. In Manchester encoding, as you've seen, we send a 1 in Manchester encoding, a 1 electrical signal, a 0 no electrical signal. So we have other encoding mechanisms that you can Google and learn about. One of them is called the non-return to zero. Non-return to zero encoding mechanism, or NR. It's called NZRI. NZRI. Okay. Then you have what we call a collision domain. A collision domain. This is a very important concept in computer networking. Now, generally, the way these particular computers have been interconnected, they have been interconnected over a shared medium. So this particular medium at the center here is a shared medium. And this particular way of interconnecting computers is called the bus topology. the bus topology. So you can think of this as the bus topology. We have other topologies such as the star topology, we have the ring topology, and we have the mesh topology. I'm also giving you this as a reading assignment. Go and read about these topologies. Generally, a topology is how the computers have been interconnected on that particular network. Now, when you have the bus topology and we have the shared medium, then the signals in that shared network are susceptible to collisions. Why? Because we can send at the same time. If this guy sends, he's sending data to this guy, and this guy is also sending data to this guy. You see, these two signals are gonna collide somewhere here. When they collide on the shared medium, then that data is gonna be destroyed. That data is gonna be destroyed, and the receivers are not going to be able to interpret it. So that is what we call collision. And generally, a collision domain is referred to as a shared network medium where collision can occur. So that is what we call a collision domain. But generally, we have a solution to this shared network medium that are susceptible to collision. That particular solution is a collision detection mechanism that is used to identify the collision. This collision detection mechanism is called carrier sense. Carrier sense multiple access with collision detection. Commonly referred to as CSMA CD. CSMA CD. So generally, how does the carrier sense multiple access with collision detection work? So we have this guy here. Let's say this guy is host A, this guy here is host B, this guy here is host C, and this guy here is host B. So with collision detection, it ensures that if A wants to use the shared medium, then A will first listen on the shared medium. Is there any signal in the shared medium? If no, then it's gonna wait for a predetermined amount of time and place data. Send data. Otherwise, if it listens and it hears someone else is using the shared medium, then it's gonna stop. It's not going to send. It's gonna wait for a certain predetermined amount of time, then listen again. So it will only place data after listening and it finds that the shared medium is not in use. However, host A and host C can still listen at the same time and place data at the same time. So whenever that happens, then that is where collision detection comes in. With CSMA CD, it can be able to actually identify that a collision has occurred. When a collision occurs, both of them are going to retreat from sending data. They're going to wait for a certain predetermined amount of time, both A and C. Then ikipata link ni haitumiki, then sasa ndio itatuma, like that. So that is how carrier sense multiple access with collision detection actually works. Okay. So other than knowing about the collision domain, you need to also know about the duplex modes. Duplex mode. The duplex mode, in short, is used to support either simultaneous or non-simultaneous bidirectional communication. So when you're talking about the duplex modes, we are talking about both the medium and the interface. This is what we call the interface. It's also called the port. This particular interface that interconnects the end station to the medium, we call it an interface or a port. So some interfaces can only operate in half duplex mode. Same as medium. So in half duplex mode, I commonly give the example of what we call the over. Huko kwetu tunaitanga over. Hizo walkie-talkie za polisi. Lazima mmoja aongee then aseme over. Akisema over, kuna button anaachilia. Hiyo button akiachilia inaachilia channel. Then huyu mwingine anaanza kuongea. So that is what we call half duplex. So in half duplex communication, you can only do non-simultaneous bidirectional communication. Bidirectional means you can send either way, but one at a time, non-simultaneous. On the other hand, with full duplex, this is like our mobile phones. Each one of us can be able to talk from either end. So the channel can support that both of us talk. So with full duplex, generally, we usually have lines that have been dedicated for sending and lines that have been dedicated for receiving. So for example, Ethernet cables from, I think, Cat5e can be able to do full duplex. Why? Because two pairs have been dedicated for sending and the other two pairs have been dedicated for receiving data. So that is what we call full duplex. And it's important that going forward, you understand the difference between half duplex and full duplex. Okay. So that is it. That is it about this chapter. So I'll just select a few people to help us in answering and discussing these questions. Okay. So Oyo, can you hear me? Oyo can take the first one. Lynn can take the next one. And this Honor 7S, who is this? Honor 7S can take the last one. So whoever is comfortable, please go first. Lynn, are you ready? I can see your mic is unmute. Help us discuss the second question.
According to me, yes, I'm talking about a collision domain. Is what can I call it? Situation whereby computers are connected using they're sharing the same medium, so they're liable for a collision that happens when one computer and another computer sends data at the same time. Exactly. A collision happens, and then the data is lost.
Exactly.
And then yes, yeah.
Exactly. So collision domain is simply a shared medium where we have the probability of a collision occurring. Shared medium where we have simultaneous bidirectional communication and we have the probability of collision occurring. Thank you very much, Lynn. Okay, so because the others have refused or are unable to respond, I'll let you read the remaining two questions and try and answer them. If you are unable to, you can go ahead and read the answers below this particular slide. Bethwell, you have something to say, or anyone else with a question? I think today we're going to stop here. Then tomorrow we pick it up from where we've left.